With this video, I'm going to go through the entire lesson that is kind of really an introduction into logarithms, what they are, how to convert it to a logarithmic form, and so forth. So we're going to learn to rewrite these, rewrite some radical expressions as fractional. We kind of talked about that a little bit in the last lesson, but we're going to do that a little bit more practice on that. But converting from exponential form to logarithmic form, and from logarithmic to exponential, going back and forth. We'll also learn how to simplify some logarithms and then do some very, very basic logarithmic equations. All right, so this is kind of a little bit what we worked on before. This is, we want to convert this radical into a fractional exponent, okay? So this is the square root of 6. Square root, now, sometimes you'll see these with the 2 here. If you don't see a 2 there, it's still the same value. It's just like a shorthand way of doing it. It's like an invisible 2, if you will. So this one is equal to 6 to the 1/2 power. The 2 here in that radical there goes on the bottom. Whatever my exponent is here, in this case it's 1, goes on top. So if we do the square root of 8, same thing is going to apply. This is still a 2 here, and this is still a 1. So this would be 8 to the 1/2 power. Okay, and let's look at this one, though. Well, this one isn't a 2. It's definitely not a 2. We've got a 4 here. My exponent on my m is 1, so this would be m to the 1/4 power. Now, if we want to go the opposite way, y to the 2/5 power is what as a radical? See if you can kind of figure that out. We're going to use the same pattern. We've got that radical there. That's going to be a 5th root, is what we call that. There's 5's here, and the 2 is associated with this y. Remember, whatever this exponent is here goes on top. Then whatever's here in this radical, at the beginning part of this radical, if you will, it goes on bottom. Okay, and last one, we've got the 7th root of x to the 6th. If we wanted to rewrite that one as an exponential form with a fractional exponent, it would be x to the 6/7. The 6 here is our exponent of the x, that goes on top. And this is the 7th root, so that goes on bottom. All right, now we're going to switch gears. We're going to talk about logarithms. Logarithms were invented. These didn't just naturally occur, but it's a way of calculating very quickly. Back before they had calculators, they did a lot of logarithmic functions and equations, and they were basically used to multiply very large numbers. And it was used when, instead of multiplying, you'd kind of convert them into this logarithmic function or method, and then you just add the two. It made it a lot easier. So instead of trying to multiply really large numbers like these two numbers, trying to multiply these two together would be very difficult if you did it without a calculator. So instead, it's easier just to convert them to a logarithm, then add the two together is how they used to do it. We don't do that so much anymore because we have calculators. We just type it into our calculator and hit enter, and it will give us the answer. However, we do use this to solve various logarithmic equations that we still do today. We'll get into a lot more of those a little bit later on in this chapter. But first we kind of have to learn what a logarithm is, and so then later on we can use manipulation. Okay, so a logarithm here, and this is a big explanation here. The biggest thing here is that you have to realize that this base here has to be larger than 0. It can't be a negative number. Okay, the rest of this I'm not too worried about at the moment. Here's where we're going to get in. So we've got this equation here, 4 cubed is 64, and that's indeed the case. 4 times 4 times 4 does give me 64. Now what we can do is we can convert this one to a logarithm. All right, and the way we do that, a logarithm has this. We've got 3 important components. First, it must say log here. We've got this lowered number here, and then we've got a little bit normal, if you will, number here, equals this other normal number here. Now the very first thing when we're converting it to a logarithm is that this number that goes on the other side of the equal sign is always whatever your exponent was. So in this case, my exponent was 3. So because my exponent's 3, I know that's going to be a 3 right here. I can fill that in. Okay, from here, if we notice here, the way I do this is I look here and I say, okay, 4 to the 3rd power. You see how 4 is a little bit lower than the 3? So 4, in a way, is lower here, and it's still going to be lower here. It's going to be down here, the 4, and then I only have one number left. That's the 64. That goes right here. That's the way I always do mine. I always just, whatever the exponent is, I write that one in first. Then my base here is still going to be lower here. It's my base as well here. And 64 just gets filled in at the 3rd spot. The way that we say this, though, is a little bit different. This will be log base 4 of 64 equals 3. Log base 4. So these are both bases. This is the base 4, and this is the base over here with the exponent. So log base 4 of 64 equals 3. All right, well, let's try that here with this one. I'm going to go through this one again. You don't need to try it on your own yet. I'll give you some ways to do it here. So I've got the same thing here. Now, notice how my negative 3 this time is in my exponent. So whatever that is, whatever's in your exponent, doesn't matter what it is. It could be an x, could be an x plus 3, whatever the case may be. And we'll get to those in a little bit. But whatever my exponent is here, we're going to write it on this side. So in this case, it's a negative 3. I just keep it as a negative 3. I don't change it at all. 2 was my base here. That's also going to be my base on my logarithm. I'm going to write it in right here. 1/8 is what's left. That's going to go right here. And it seems a little bit weird because we have a fraction there, but that's okay. We can have fractions there. And if you realize that 2 to the negative 3 is indeed 1/8. Our rules of exponents tell us that we have to move this down, so it would be 1 over 2 cubed, which is 1/8. So anyway, that's not as important at the moment, but this is indeed your answer here. Now what I want you to do is I want you to try these two. So go in here, work out both of these, convert them both to logarithmic form. So push pause on the video right now, work these out. After you've obtained your answers, come back and push play, and then we'll review it. There we go. Hopefully you could identify this. The 3 was my exponent. That goes on this side of the equal sign. Same thing with the 2. That was my exponent. Goes on this side of the equal sign. 2 is my base. That goes down here. And 8 fills it in. All right, let's try another one here. Try both of these two. Push pause on the video now. After you've obtained your answer, come back and push play. Check your answers. Okay, hopefully this is kind of making a little bit of sense here. Now we're going to spice it up just a little bit. I'm going to give you the logarithm. You're going to have to write the exponential form of it. If you're not sure, do this one first. Do number 2 first. That might give you a clue of how to do number 1. So push pause on the video now. After you've obtained your answer, come back and push play. Check your answers. Now hopefully you could identify that this m, m was your equals. That means it's going to be in your exponent. And the 5 was your base. Y was just moved to the other side, basically. This one's the one similar to the ones that we've just done. And remember, 16 to the 1/2. And it's hard to tell what 16 to the 1/2 is, but if you remember for what we were doing at the very beginning of the video, you remember that we had this is the same thing as a radical. Okay, this would be 1, 16 to the first power. 2 would be our radical, so this would be the square root of 16, and the square root of 16 is indeed 4. So that one does actually make sense. All right, try these two. Push pause on the video now. After you've obtained your answer, come back and push play. Check your answers here. Okay, we should start to realize those, start to get a little bit better with those. Now we're going to kind of throw you a little bit new problem. And it just says evaluate it. Evaluate it means basically to simplify it. We've got log base 9 of 81. And we're supposed to simplify that one. This is brand new, so it's very confusing at times, but let's just simplify it a little bit more. Okay, so log base 9 of 81, well, we don't know what that equals. And when we don't know something in math, what we'll usually use is we'll use a variable. So this right here is equal to something. We don't know what it's equal to, so we're just going to use a variable. And the variable that most people in math like to use is x. You could use anything you wanted to. That wouldn't change anything. So log base 9 of 81 equals x. Well, if that's the case, we can convert this one to exponential form. If we do that, remember our x comes up here as our exponent, 9 is our base, equals 81. 9 to the what power equals 81? Well, that would have to be squared, so 9 to the second power. So our answer would be 2. So when we're asked to evaluate this one, log base 9 of 81 is really just reduced down to 2. That's it. Okay, now we've got this one here. I want you to start thinking about what you can do here. Okay, now remember we're going to convert this equals something. We don't know what, so we'll say x. We convert it to exponential, we convert it there. Now we're going to convert it to exponential form. This would be 3 to the x, 3 to the x power. 3 to the what power gives us 27? Well, 3 times 3 is 9 times 3, so it would be 3 to the third power. So this one would reduce down to plain old 3. All right, now I want you to try these next two here. Push pause on the video now. See if you can work these out by hand. After you've obtained your answer, come back and push play. Check your answers here. Okay, so this one's kind of the same. 4 to the what power gives us 256. Hopefully you can identify that as 4. This one's an interesting one. Some of you may have forgotten. We've covered these in the past, but it's been a long time since we covered these. Anything raised to the 0 power always gives us 1. Every time it gives us 1. So anytime you get one of these something to the something power gives us 1, it's always going to be a 0 power here. It doesn't matter what this number is here. This always has to be 0. Okay, the only exception would be 1 to the first power would give us 1. Also 1 to the 0 power would also give us 1. Kind of weird, but either way would work. That's the only exception. But anytime you get this one and you have something to the 0 power, or something to the any number raised to a power that equals 1, this is going to be a 0. Try both of these two now. Work these out by hand. After you've obtained your answer, come back and push play. Pay attention to number 1. That's going to be an interesting one. All right, now on this one, you see right here, I've got 7 to the x power gives me 7 to the 4th. Well, 7 to the x, that means these two here, these bases are the same. That means the exponents have to be the same. And if the exponents have to be the same, this one's a 4. That means this one has to be a 4. There we go. Now over here, we've got 2 to the what power gives me 1 over 16. So 2 to the what power, we have to remember that this is going to be a negative exponent. That's why we end up with a fraction over here. And then we have to figure out what time 2 to the what power gives me 16. Well, that's to the 4th power. 2 to the 4th power would give me 16. In order to get the fraction here, it would have to be a negative power. 2 to the negative 4 gives me 1 over 16. All right, try these two now. And these are just like the ones that we just did. So if you need a little help, go back and look at those real quick. Push pause on the video now. After you've obtained your answer, come back and push play. Check your answers here. So this one's really similar to the first one that we did in the previous problem. And this one is real similar to the first one, or the second one that we did in the previous problem as well. 3 to the what power gives me 1 over 27. That would have to be 3 to the 3rd power gives me 27. And to get it as a fraction now, 1 over that number, I need a negative. So 3 to the negative 3 would give me 1 over 27. All right, log base 10. Now this is one of the most commonly used ones. Okay, and because of that, we have a shorthand way of writing it. We don't want to write log base 10 all the time. So now we just write log. So when you see one that just says log and it does not have a base on it, it is log base 10. They have the same exact properties as all the other logarithms, only now it has a base 10, and we just have a short way of writing it. The other most commonly used one is a natural logarithm. Okay, logarithm with the base e. Now we know our number e from our previous lesson. Okay, that's 2.718 and change. So this one is a log base e, but instead of writing log base e, we'll just write ln. Natural logarithm is where we go. But it shares the exact same properties as the rest of them. So if I ask you to write this one in exponential form and this one in logarithmic form, I'd like you to do these two now. And you can go back to our previous discussion there on what your base is on this one and how to write this one as a logarithm. We don't write log base e, we write something else. Okay, so push pause on the video now. Work out these two problems and come back and push play. Check your answers here. Okay, this one is a base of 10. So 2 is our exponent, our base was 10. This just moves over to the other side. Now this one, normally we would write log base e, but that's too long, so our short way is just to write an ln. That means the same thing as log base e. Both of those two meaning the equivalent, but this one's the way we write it in a shorthand. So you'll see this way written all the time when we're using a natural log anyway. All right, try these two. After you've obtained your answer, come back and push play. Check your answers here. So hopefully you're starting to identify these, when to write in what the base is on this one and how to write it as a logarithm on this one. Okay, now this one, we're going to use our calculator to evaluate these two, so we're going to have to figure out where the log button is on our calculators. Okay, and this one says log 2, and this one is log 35.2. Okay, so we're going to have to take out our calculators and plug those in. Okay, so I'm going to escape out of here. Let me bring up my calculator here. And this one was a log 2, so we're going to go right over here. Right here is our log button. Okay, so all I have to do is hit this, and this is on 84. We'll do the inspire in just a second. Log, and then we just write 2. And we hit enter. And there we go. Now we have to round this one. It says round your answer to the nearest 4 decimals. So we go over 4 decimals. We're going to round this one. And it will stop right there. This one will round down, so this will be 0.3010 or 0.301. Either one will work fine. When you do it on the Inspire, let me bring that one in. The log button is just a little bit different here. Log button is right above this 10 to the x power, and because it's in blue, we're going to have to hit Control. So we'll hit Control, Log. Now you notice on this one, it automatically has something here as the base. Since this one is a base of 10, I'm just going to fill in 10, and then this one is 2. So I move over here, toggle over to the 2, and I hit Enter. Now you notice on this one, it just kind of gave me the same thing. It really didn't help me at all, did it? And this one we're asked to round it, so we need the approximation answer. And the approximation looks like these bacon strips right here, right above the enter sign. In order to get that, I'm going to have to Control, Enter. Then it will round it for me. And it'll give it to me in decimal form, which is nice. Now, the next ones I'm going to talk about are going to be a natural logarithm, so let's figure out where those are at. The natural logarithm is right next to log. Over here it says ln, and we're going to use the same procedure. Control e to the x power, which gives me an ln, and then you just type in whatever the number is. If it was 2, you just type in 2. Again, that gives you 2u as a just the same thing, so we want to hit our approximation. Control Enter will give us our approximation. Now let's bring in the TI-84. On this one here, the natural log is right here, ln. It's the only difference. It's right below the log. It's just the natural log. So, all right, so let's try. We've got those. Go ahead and finish those off if you haven't already seen the answers. You can at least get some practice on them. Type both of those into your calculator right now. And then come back and push play. This one was your first answer. This one was your second answer. And again, you can round this one to 0.301 if you wanted to. And if you put the 0 in front, that's fine too. It won't hurt us at all. All right, try both of these now. Push pause on the video now. After you've obtained your answer, come back and push play. Check your answers. Hopefully you're starting to get the hang of this just a little bit here. This one's interesting, and we've got this radical 2. Just type it in just like you see it here. Same thing with this. Use parentheses, type it in just like you see it here. You'll get the answer that you want. So push pause on the video now. After you've obtained your answer, come back and push play. Check your answers. All right, now we're going to move on to something a little bit different here. These are very basic logarithmic equations. And when we're dealing with these, we're going to be solving it for x. We're trying to find out what x equals. Well, it's a little bit hard to find out what x equals just in this form. We've got, this is in, believe it or not, an exponential form. It's not in logarithmic form. This is 5 raised to this power. Okay, this is all the exponent, equals x. So in order to find out what x equals, oftentimes you'll get this one, you don't know what to do. What I would do first is convert it to the other form. This one's in exponential form right now, so we're going to convert this one to logarithmic form. And that sounds a little bit weird, but let's think about it. We've done this several times already today. We take whatever the exponent was, in this case this big logarithm here, and we put that on the other side of the equal sign. Then we're going to use this as the base of our logarithm. So that's all I did. I took this entire thing here, moved it to the other side of the equal sign. Then 5 was my base. I moved that down. Whatever I'm left with, in this case it's just x, goes here. Now let's look at this. Both of these are log base 5s, log base 5 of x, log base 5 of 8. So because they're both log base 5 here, these two can just cancel out. That means these two components here have to be the same. This one's an 8. That means this x here has to be an 8. X has to equal 8 in this case, because these two here are both the same with a log base 5. So that means this x here has to be the same as this one over here. So let's spend some time and go over this one now. Same process. We're going to convert it to logarithmic form. Once we convert it to logarithmic form, we find out that they both have log base 7. So that means these two components here have to be identical. So that means this one is a 12, that one here has to be a 12 as well. So that means k has to equal 12. Okay, using that same logic, we need to go in here and figure these out. Now these look like really, really complicated equations. They've got a logarithm on both sides, but really it's not. These are both log base 6, log base 6. In that case, if these are both the same, that means these two components right here have to be equal to each other. So now all we do is set both of these equal to each other. 4x plus 10 is equal to x plus 1, and then we solve it. So push pause on the video now, work through your answers. After you've obtained your answer, come back and push play. check your answers here. Really, these look like really daunting ones. Because they both have the same log and the same base, these two components here have to be equal to each other. So all we do is 3a plus 8 equals 5a plus 10. These two in parentheses here equal each other. That's it. And then we solve it. Okay, this concludes the lesson for today. You can go back in and watch it again if you'd like to, or I have some other videos as well with very specific examples that you can go through as well. But anyway, either way you want to do is fine. You can go back in and whatever works for you.